Good afternoon, ladies and gentlemen. Today, we are going to solve my second exam for my Calc 2 class. And in fact, I'm teaching two classes, and this is the class from the 7 p.m. class. So, I told you guys, if you guys subscribe, then you guys should know, yeah, we are going to do it. And as usual, you can find the file in the description, right? And I have the printout right here. And I wrote down the first question right here. The usual style is that my first 6 questions are multiple choice, and then the last 7 questions are short work. And you can try the questions out first. And I promise you guys, next time when I do live stream, I will plan ahead and I will give you guys the file ahead of the time, so that if you want to try it first and then watch me do the questions during live, that would be better, right? So hopefully you guys are doing well. Let me know how you guys are doing, right? Let me know where you guys are from. Right now is 5:41 p.m. in LA, right? So let's go ahead and solve this. Here we go. All right, it says the air in the room, well, the room is 200 cubic meters, contains 0.15% carbon dioxide initially. Well, that's a lot of carbon dioxide. That's not that good. But anyway, though, fresh air is coming in with only 0.04% carbon dioxide. All right, so you can imagine it comes into the room and the flow in rate is 2 meter cube per minute. And just imagine that once the air comes into the room, we are going to blend in the air together, all the stuff, well mixed air will flow out at the same rate as well, right? So this is the usual mixing question in differential equation. And we are going to let A of t to be the amount of carbon dioxide in the room. By now, if you read all this, you might be like, oh my god, this question is so hard. But don't worry, man. This is just a multiple choice question. This is the first question. All I'm asking is, do you understand what this is representing in this situation? What's the limit as t goes to infinity of A of t? You don't need to do differential equation for this. So let me know what you guys think, right? So I will look at the answers that you guys have right here. So go ahead, let me know. Go ahead, let me know. So read the question and let me know what you guys are, let me know what you guys are getting for that. And perhaps I want to adjust the camera angle a little bit. So just give me 1 second. Let's see. I'm just going to. All right. Perhaps it's slightly better. Just want to make it a little bit closer, right? Okay, so all you have to do is, this right here is asking you what will happen in the long run. Well, because we have better air comes in and the air is with 0.04% carbon dioxide, right? But you have to be careful though. The A of t stands for the amount of the carbon dioxide. So you have to look at the volume, right? And in fact, all you have to do is, in the long run, all the room will be just with this percentage. So for the answer right here, this is actually very nice. It's just 0.04%. And how big is the room? Well, 200 meter cube. So we can just take this and then multiply by 200 meter cube. And 200 and then percent cancel, it's just 2 times this. So this is 0.08 meter cube per minute. And I'm serious, this right here is it for the first question. However though, for my 4 p.m. class, you guys were not so lucky because I actually asked you guys to solve for the differential equation, right? So yeah, let me also demonstrate that as well. Anyway, here's the situation. Again, you have the room right here and you have the air comes in and then the air goes out, right? Well, you have to know that here, the amount of carbon dioxide is A of t and it changes, and you have to know the A dt, the rate of change of the amount over time. Pay attention to 2 things. In general, it's just rate in minus rate out. So let me just put that down right here for you guys. But this right here is how fast the carbon dioxide is coming in, right? So rate in for the carbon dioxide and then minus the rate out. Well, how do we calculate the rate in? two things that you have to know. First, you have to know the flow-in rate, which is 2. So right here, I will just have to put down 2 right here. And again, this is the flow-in rate. How fast is the new air comes in, right? But not all the air that's coming in is carbon dioxide. Well, when you come in, you also have to look at the concentration, which is that, namely 0.04%. And the red number here is meant to be for the concentration. All right? Okay, cool. Now we have to subtract rate out. Well, we still have to do the same thing. You have to multiply by 2 first, right? This right here represents the flow out rate. So I'll just put this down. This is the flow out rate. Why? Because it says it's going out at the same rate. Cool. Now, we also have to figure out the concentration, but what's the concentration of the carbon dioxide that's actually going out? You have to remember. Concentration, so I'll just put this down here for you guys real quick. In general, is the amount of whatever you're looking for divided by the volume. So here's the deal. The amount of the carbon dioxide in the room is A of T because it changes over time. And the room is this big, right? So all you have to do is actually just do A. You don't have to put down the parentheses T. A is okay, right? Especially later on, you will have to solve the differential equation for my 4 p.m. class. So A and then divided by 200. So that will be the differential equation that you have to solve. And of course, you can go figure out other things, but the theta is the most important part, right? So that's this right here is for my 4 p.m. class, but this right here, it's the main deal. All right? Okay, cool. So that's the first one. And I know not a lot of you guys like word problems, but this isn't so bad. Okay, let's see. And let me know if you guys are taking Calc 2. If you are, hopefully this right here will be helpful. And I'm going with the typical pace as the typical like Calc 2 class, semester-long Calc 2 class. And by the way, the textbook that we use is Stewart. So if you are interested to know. All right, second question, right? And then I accidentally printed out on the wrong paper, but it's okay. So second question. This is the Pikachu question. Pikachu thinks that the following integral diverges. So number 2, here we have the integral going from 0 to 3. And we have 1 over parentheses x minus 1 square dx. So Pikachu thinks this right here diverges. What do you guys think? Well, all we have to do is just work it out, right? So let me see. Do you guys have anything to say? Is it converge or diverge? All right, does this converge or diverge? So I see one diverge so far. Diverge, diverge, cool. Notice the following. When we integrate from 0 to 3, and this is x minus 1, right? That means this right here is an improper integral because we have a vertical asymptote at x equals 1, right? So to take care of this, you actually have to break it down into 2 integrals. The first one will go from 0 to 1, and technically, because we go from 0 to 1, exactly 1, this right here will give you the vertical asymptote, so you actually have to avoid exact 1. A little bit less than 1 is okay. So you actually have 1 minus, right? And if you write this down like this, you are taking a limit. Just keep that in mind. All right, so that's the first integral right here. And then we have to add the second integral. We have to pick up from here, but again, do not put down 1. Technically, you have to avoid 1. It's actually 1 plus. And then you continue it until 3. And then you have 1 over x minus 1 to the second power dx. All right, the truth is, if one of them diverge, then you are done. That's C. This right here, take care of this real quick. I'll do a U sub, that U equal to x minus 1, and you'll see du is just equal to dx, which is very nice. And if you look at the first one, I will do this one in blue. This right here is equal to the integral when x is equal to 0, right? This right here is x equal to 0. U will be negative 1, right? And when x is equal to 1 minus, right, let's see, that will be 0, so u will be going to 0, right? And then we just have 1 over, let me see, 1 over, and inside will be u, and then we have that square, and then we have dx, which is the same as du, right? So that's what we have, and then we just have to do the usual work and see what happens. Integrating this, we get negative 1 over u, and then we go from negative 1 to 0. And again, right here, technically, I do 1 minus, put it here. This right here should be 0 minus. Why? Think about this as 0.99, right? 0.99 minus 1 is negative 0.001, which is negative number, right? So it's 0 minus. So do it carefully, and then just see negative 1 over 0 minus. That's the first part, and then minus the second part, which is negative 1 over negative 1, like so. Cool. Now, negative 1 over 0 minus, this right here gives you positive infinity. Right? This right here gives you positive infinity. And then that's positive 1, and then we have minus 1. And guess what? This right here still gives you positive infinity. And if you work this out, this will also give you positive infinity. So you are going to get just diverge for that, right? So I'm going to leave that to you guys. But all in all, the answer to this right here actually diverges. So Pikachu is correct. And if you guys don't know this already, yes, for my calculus exams, there will always be one Pikachu question. All right, now, some of these questions are just mechanical work, all right? So I'll just kind of deal with this a little bit. Like for example, number 3, consider the integral going from 0 to 8, and then we have natural log of 2 plus x squared dx, all right? But what we want is, we're not going to compute this. We're actually just going to find the Simpson's rule when n is equal to 4. That's all. Although you can integrate this easily, right, with integration by parts and then plugging numbers, but it doesn't really matter. I'm just asking you guys for the Simpson's rule, right, to do this integral. So to do the Simpson's rule, this is how you should do it. Right? This is how you should do it. First off, compute the delta x. Delta x is just going to be 8 minus 0, and then divided by the n value, which is 4. So as you can see, this right here will just be 2. That's pretty nice, right? And then I'll just tell you, as 4 is going to be the following. This is equal to delta x is 2, so we have 2. And don't forget, we have to divide this by 3. And then what we are going to do next is, we are going to call this to be our function, namely just f of x. Right, just call that to be f of x. And we have to plug in numbers. What numbers are we going to use though? Well, the interval goes from 0 to 8, right? So just go ahead and draw the interval real quick, 0 to 8. You don't have to draw the graph, just draw the interval, it's good enough. And we are going to cut this into 4 pieces. So of course, you know, each one is going to be with 2, like so. Write this down because this right here will tell you the x values that we are about to use. First off, we'll use 0, and we just need to put 0 into f, so we have f of 0. Cool. Now, next, you have to remember, we will have to multiply by 4 when we plug in the next x value into our function, and that's just what the Simpson's rule is. And remember, you are doing the test, so you don't need to think about proof, just work this out, be happy with it. And the truth is, if you guys download the file, you guys will see that I actually provide the formulas to the students, but I don't call them formulas, I call them to be the friends. Anyway though, 4 times f, and then the next value is 2. And then is what? The next coefficient is 2. So you do 2 times f of the next x value, which is 4. And then just continue. The next one is going to be 4, and then the next x value is 6. And lastly, this right here is the last x value. The coefficient is actually just 1. You don't have to put that on anything. So just put on f of 8, like so. All right? And then work this out. You will get approximately, all right, so for this right here, I forgot to write down the answer, so I actually don't know what the answer is. I think this right here, the answer should be, yeah, 2. I didn't know write down the answer for that, so there's no way for me to do it by hand right now. So just 2 point. I think this is the answer. I don't know though. But you know what? Let me not write this down. Right? You do it. On the test, do not just put down, you do it on the test. You actually have to do it and show me what the answer is, right? I just forgot to write down the answer, but like, yeah, all the answers, they look kind of similar, so I really don't want to put down any wrong answer. But if I remember correctly, the answer should be C. So I'm going to leave this on the board. If you guys have the time, well, go ahead and work that out. And in the meantime, let's move down to the next question. Okay, so for the next question, it's a limit question, and we are going to find out which of the following is equal to 0. So number 4, so which is equal to 0, right? So I'm not going to write down the whole thing because, just on the, I'm just going over those things for you guys. So anyway, choice A, here we have the limit as x goes to infinity, and here we have 20/20's root of x over the bottom is natural log of x. So that's the first one. Okay. Next, we have B. Here we have the limit as x goes to infinity. And you can expect we are going to be using 20/20 again. And here I have x times sine of 20/20 over x. Next, C. Here is the limit as x goes to infinity, and we have x to the 20/20 over 2 to the 20/20, no, not 2 to the 20/20, 2 to the x power, and then D, we have this, the limit as x goes to infinity, 1 plus 20/20 over x raised to the x power. And for the last one, we have none of the above. All right, so this right here shouldn't be too bad. You guys should be able to just look at it and tell me what the answer is. And so let's see. Thank you to Raphael, 21.5872. All right, so 21.5872. All right, so let's see. Oops, forgot the K. Thanks to, let me just get your names right, but I'll just write down your Raphael. Cool. All right. Now, how about this one? How about this one? How about this one? How about this one? Which one is the answer? I'm going to give you guys about 10 more seconds. 10 more seconds, 10 more seconds, 10 more seconds. The answer is, well, this time I'm not going to trick you. I'm not going to do anything like last time anymore, right? So I'll just tell you guys what the answer is. So, C. Yeah, if you were here during the last live stream, you know what I was talking about. But anyway, though, the answer is C. And let me just go through this real quick for you guys, right? And I'm not sure if you think what you guys think about the test, but like I'm just gonna work out. Anyway, though, first off, this right here is actually going to be infinity. You can just work it out really easily. And this right here is actually going to be just 0. You can also just work it out really easily. How do we know this and that are just the answers right away? Because we have the secret weapon. So I'm not sure if you guys have used this before, but in my class, I actually use this. So here's the deal. When you have x is going to infinity, well, if you compare all the functions that go to infinity, especially the common ones, let me tell you, ln x, it's the smallest infinity that you get. How small? It's so small that I'm going to put down 2 less than symbols. Smaller than what? X to the p's power, and then this is smaller than b to the x power, and this is smaller than x to the x power. And of course, we do have some conditions. Remember that for the p, it has to be greater than 0, and for the b, it has to be greater than 1. How small are these? Well, so small if you do the ratio of one and the other. If the top is the smaller function, the ratio of the functions will go to 0, right? But if you look at the first one, this is x to the 20, this is the same as x to the 1 over 2020's power, right? Because when you have the radical, the index is the same as the fractional power. So here we actually have x to the 1 over 2020's power over ln x. But you see that this right here, it's actually bigger than ln x. How much bigger than though? Big enough so when you do the ratio of this over that and take the x approaching infinity, you end up with infinity. That's it. Quick and easy. And on the other hand, if you look at x to the 2020 divided by 2 to the x, well, this right here belongs to here. 2 to the x is belong to here. So as you can see, the top is so much smaller than the bottom. And how much smaller than? Well, if you take the limit as x approaching infinity, the ratio will go to 0. So that's pretty much it. And I'm also going to tell you guys the other secret weapons. Technically, we have 4, but for this part of the course, I'm only going over 3. The next one is the limit. For this limit, please do not do L'Hopital's rule, right? Seriously. This right here is the limit as theta approaching 0, and then we have theta approaching 0, sine theta over theta. This right here gives you 1. And for this one, please don't do L'Hopital's rule, right? And how can we utilize this for that though? Well, let me show you. If you look at b, which is the limit as x approaching infinity, and we have x times sine of 2020 over x. And by the way, on the exam, you are done already. You can just move on. But I'm going over the lessons, just to enhance your understanding and learning. That's why I go over each and every other choices. But once you know the answer is C, just move on. Anyway though, back to this, how do we solve that? If you put infinity into here and here, you will get, this is an infinity times, put infinity to here, 2020 over infinity is 0, sine of 0 is 0, so this is a infinity times 0 situation, which is not good, right? It's indeterminate form. So what we can do is bring this, you guys know it, down, down, and you get the following. This right here, it's the same as the limit x approaching infinity, sine of 2020 over x, and then over, bring this down, down, so you have 1 over x, like so. All right? And then, again, seriously, just don't do L'Hopital's rule. That's why I put this as a multiple choice question, so I don't need to see the things that I don't want to see. Anyway though, right here, I'm going to let theta equal to 1 over x. Notice, as x is going to infinity, theta will go to 0 because we have 1 over infinity, right? So this limit becomes the limit. So let's see, theta will be approaching 0. That's great. And then the bottom is nicely equal to theta because we said so, right? And then right here on the top, you can see that, okay, this is 2020 over x. Too bad. If I do the 1 over x, I get this taken care of. That's not so good. You know what we can do though? Instead of 1 over x, let me actually change it a little bit. Let theta equal to actually the inside. Let's put down 2020 over x. You will see it works out very nicely. Here, you get sine. This becomes theta, right? And then you might be wondering, how do we take care of the 1 over x then? Well, if theta is equal to 2020 over x, we can divide it by 2020 on both sides. So we get, let me see, 1 over x divide 2020 on both sides, we get theta over 2020. So this will actually be a better choice for theta. Then we put this right here, so we have theta over 2020. Well, this 2020 can go up, and then it's just a constant multiple, so it can go to the front. So this right here, the 2020 goes all the way to the front. And then for the rest, we'll just have the limit as theta going to 0, and then we have sine theta over theta. But you know, this right here is just nicely equal to 1. So all in all, this right here equals 2020 times 1, which is 2020. All right, very cool, huh? So this is another secret weapon that you should definitely keep that in mind, right? And then I'm also going to show you guys for the choice D. That one is actually not so bad at all. For this one, what we can do is use the fact. So right here, let me just put that down for you guys. This is the fact. What it says is that if you take the limit as x goes to infinity, 1 plus a over x raised to the bx power, this is nicely equal to e to the ab power. And again, for all this, I covered it in class already, and as I told you, they are your secret weapon. Because with this in mind, this right here is just actually one line. Because notice, in our situation here, a is 2020, and b is just equal to 1. So I will just write that down for you guys. A equals 2020, and b is equal to 1. So all in all, this is just e to the 2020 times 1, so it's just e to the 2020's power, like that. And guess what? We are done. That's it, right? All right, so again, this question can actually finish, you can actually finish this in like 10 seconds by using the list, right? But I just want to go over everything for you guys. So that's pretty much it. And yeah, what do you guys think about this? Hopefully so far so good, and hopefully everybody is doing well. And thank you guys so much for coming to the live stream. And let me know where you are from. All right, now moving on to question 5. I will try to finish this within like within an hour. Yeah. Oh, okay, so the first page is done. Now, second page. Ooh, this is one of my favorite. Number 5. Here we are going to solve a differential equation. dy dx is equal to y squared, and also we have initial condition y of 0 is equal to 1. Well, let me just give you guys an honorable mention. On the side, if you have dy dx, if this is equal to y and y of 0 is equal to 1, do you guys know what the solution to this is going to be? Do you guys know what the solution of this is going to be? It should be quick and easy. This right here is just e to the x. Perhaps this right here is the first differential equations that you guys have ever solved, right? But anyway, when you have y being to the second power instead, it's also just as nice. All right, divide this on both sides and multiply dx on both sides. So we're looking at this as 1 over y squared, and then we have the dy, and then the dx. From here, go ahead and integrate both sides. Integrating 1 over y to the second power, it's the same as integrating y to the negative 2. Do whatever you want to do. You can negative 1 over y, and don't worry about the plus c, just put it down on the right hand side. Integrating dx, we just get x, and then here we go plus c1, right, the first constant c1. And the truth is, it's actually not so bad to plug in x and y into here and figure out what the c is. So in this case, we don't need to label too much. Because when x is equal to 0, we know y is equal to 1. So let me just put them in. We have negative 1 over 1 is equal to 0, and then plus c. So c is just equal to negative 1. Great. Now, put this back. We have negative 1 over y equals x minus 1. Right? C is equal to minus 1. Now, to solve this, what we can do is just multiply everybody by negative 1 first. Depends on how you want to do it. And we get 1 over y equals negative x plus 1. Yeah? And then in the end, we just take the reciprocal on both sides. So we get y equals 1 over negative x plus 1. Better yet, I'm going to purposely write it as 1 over 1 minus x. Why? Because this is the best friend, which is going to be happening, in the third part of my course, namely sequence and series, and also power series. All right, so that's going to be another secret weapon coming up next. All right, number 6. This right here is a theoretical question. Suppose that, when we have the integral going from 1 to infinity, let me just write it down, otherwise it doesn't make too much sense. Suppose the integral going from 1 to infinity f of x dx. Suppose this right here converges. And furthermore, I'm going to say f of x is greater than or equal to 0. Namely, the function is never negative on this interval, so for x is greater than or equal to 1. The question is, which of the following also converges? And I'm going to give you guys the choices. The first one, the integral going from 1 to infinity, and we have x over f of x dx, and then b, integral, and we have 1 to infinity, square root of f of x. C, integral, we have 1 over f of x. D, integral going from 1 to infinity, and we have f of x divided by x, right? And to make the multiple choice question harder, I included none of the above. But let me tell you, it's not the answer, so let me not put it down. So now, take a look. What do you guys think? Which of this right here also converges? So some of you guys might feel slightly uncomfortable because right here we don't have the actual equation for f of x, right? But one strategy is just think about one integral that you know actually converges and then just kind of test it out. Again, you're not trying to do like some rigorous proof. You're just trying to figure out which of this is the correct answer. And I recommend you guys, try to let f of x equal to 1 over x squared. That works out actually pretty nicely. So that's actually how you can solve this multiple choice question. And I know some of you guys are putting down the correct answer. The answer is actually not B though. The answer is actually not B though. Why though? Let me show you. The integral 1 to infinity. Suppose the f of x is x squared. Right, this right here, by the p integral, it converges, right? But if you look at the square root version of it, if you have the integral from 1 to infinity, if you take the square root with the same function, which is this one, oops, wrong color, sorry, dx, square root of 1 over x squared, well, on this interval x is positive, so you don't need the absolute value, you just get 1 over x dx. This guy actually diverges. And whenever you are giving an example like this to prove a statement is false, that's called a counter example. So this right here is a counter example to show this right here is false. Well, we have A, C, and D. Which one? It's not C, it's actually D. D is the answer for that. If you test out with 1 over x squared, you put it here, 1 over x squared. It's just x squared. Integral going from 1 to infinity of x squared, of course, diverges, so no good. This right here, well, it's not only you can test it out and then just try to see which one works or whatsoever, you can legitimately show that this is less than or equal to the integral 1 to infinity f of x dx. This right here is always true with all these conditions, right? This right here is always true because you have f of x right here and then you are dividing x, which makes the function inside smaller than the original function. Therefore, by the comparison theorem, since this right here converges, this right here also converges, and again, by the comparison theorem, right? So that's how you can do it. And for the other ones, I'm just going to let you have fun with it, test it out, and you'll see that they are not always true. Yeah, in fact, some of them might always be false. But anyway, though. All right, so no more multiple choice questions, no more multiple guess questions, actually. All right, number 7, it's a semi-hardcore question, right? So I'm going to first write down the question and we'll erase that. So number 7, we have 2 parts. The first part is just solve this differential equation, y squared minus 3y minus 4. And I also give you guys the initial condition. So I'm going to just erase this right here. We have this, and also we know y of 0 is equal to 1. It's the first one, right? And then this is part A. And then for part B, we want to find the equilibrium solutions. And this right here is actually just 2 points or so because they're just very straightforward. This right here takes some time, but anyway, let's do it. Everybody has to go to the left-hand side. So divide this to the left-hand side. And then multiply dx on both sides. We have 1 over this guy, y squared minus 3y minus 4 in the y world. And then we have the dx. And we're about to integrate it, right? But for the left-hand side, we will have to do partial fractions. So have a look. When we factor this, well, I need some more space. Here, right here, I will have to factor it as what? Y minus 4 times y plus 1. Okay, that should work. Yeah. Okay, integral some number over y minus 4 plus some other number, or maybe the same number, I don't know, y plus 1 in the y world. And then the left-hand side, let me just keep it because I haven't done any integration yet. Now, of course, do the cover-up method. To figure out this number, we go back to the original and we cover up with the same denominator, namely y minus 4. Cover this up. How can y minus 4 be 0? Y has to be 4. And you put 4 right here. So we have 1 over 4 plus 1, which is 1/5. Cool. Now, here we have y plus 1, right? Cover this up. Y has to be -1. And we put -1 in here. 1 over -1 minus 5, that's the answer. 1 over -1 minus 4 is -1 over 5. Right? So that's what we have. And then let's just go ahead and do the usual business. I'm going to factor out the 1 over 5. So here we get 1 over 5. And then this is just y to the first power. So we get natural log, absolute value, and this is y minus 4. And the coefficient right here is 1, so you don't have to divide it by 1, doesn't matter. And then continue, minus 1 over 5, same thing, natural log, absolute value, y plus 1. Done. On the right hand side, integrating this, we get x, and then plus c1. And right now, you might want to just solve for the c if you would like. If that's your thing, go ahead and do that. But I think I'm going to, let's see if that will give me, I'm going to clean things up a little bit and then I'll solve for C, yeah? So for example, this and that, we can combine it into just one natural log. So I'm going to write it as 1 over 5, natural log, absolute value, put this over that, y minus 4 over y plus 1. By the way, whenever you are doing the partial fractions, whenever you know you have to combine the logarithms, let me tell you, put down the smaller factor first, y minus 4, and then you see y plus 1. This way, when you do the partial fractions, the second number will be negative, so you can just do this over that nicely. So that's just a quick thing. Anyway, this is x plus c1, and then perhaps I'll solve for y first, and I'll solve for the constant c. All right, multiply everybody by 5. So I'm going to put this down, multiply everybody by 5. And then this right here is natural log, absolute value, y minus 4 over y plus 1. 5 times x, of course that's 5x. C1 times 5, what's the answer for that? Help me out. C2, yes, very nice, right? Don't you love this so much, right? 5 times C1 is just C2. So this right here is equal to C2. That's it, very nice. All right, e to this power, e to that power, cancel these guys out. Technically, you still have the absolute value. So y minus 4 over y plus 1. Now check this out. E to this power, so you maintain that, e to the 5x. But because we are adding this and that in the power, this is the same as this is the same as e to the 5x times e to the c2. But because c2 is a constant, e is also a constant to a constant power is still just a constant. So we are going to write this as c3. Man, seriously, don't you love that so much? So let's put down the c3 in the front, right? Great. Now, let's see. We are going to just get rid of the absolute value. Now, how do we get rid of the absolute value? Seriously, just get rid of the absolute value. And then, don't forget to put down the plus minus on the left-hand side, just to be legit. The left-hand side, we get y minus 4 over y plus 1. And that's equal to positive c3 is a constant, negative c3 is also a constant. Let's just put it down as c4. So we have c4 here, and then e to the 5x. All right, very cool. And now I'm just going to put in the constants. I think it's enough simplification already. Well, when y is equal to 1, right, x is equal to 0, y is equal to 1, So putting 1 in here, 1 minus 4 over 1 plus 1 equals C4 e to the 5 times x, which is 0. Good. And that will be 1. So that means C4 equals negative 3 over 2, so negative 3 half, like that. And then put this right here. So we have y minus 4 over y plus 1 equals negative 3 over 2 e to the 5x, like this. Right? And I think if you, well, in the direction here, I actually told you guys to solve for y of x. So, in fact, we're not exactly done yet. Let's do a little bit more. I'm going to multiply both sides by this denominator, right? So just y plus 1. But we also have the 2 right here, right? So I'm also going to multiply the 2. Just multiply the common denominator on both sides. So we get 2y plus 1. This times this, we get 2 times that, which is, let me just put that down to y minus 4. And then this times this, the 2 cancels, we have negative 3. And then we have the y plus 1, and then e to the 5x. And the rest is just work out the algebra, right? So this is 2y minus 8 equals multiplying negative 3, and then e to the 5x, y, negative 3, e to the 5x. Yeah. Now, I'm going to move this to the other side, and I'm going to move this to the other side. Because they both have the y, I'll also factor it out. So I will have 2y, but the y will be factored out. So have a look. 2. Move this to the other side, becomes plus 3e5x in the exponent like this, and then the y. And then I'm going to move this to the other side, it becomes positive 8. Let's write that down first, and then minus 3e5x. Lastly, divide this on both sides. So ladies and gentlemen, y as a function of x. This is not multiplication, y as a function of x. This is equal to this guy, which is 8 minus 3e5x over this 2 plus 3e to the 5x. Alright, so this right here is the solution to that differential equation. Alright, how do you find the equivalent, sorry, not equivalent. This right here is the equilibrium solution, right? Equilibrium solution. So for part B, let me just do it real quick. For the equilibrium solution, if the differential equation is based on y only, you just have to make dy dx equal to 0 and solve for y. That's it. So for part B, just need, right? Just need dy dx. We just have to set this to be 0. That's it. What's dy dx? Which is the same as y squared minus 3y minus 4, and set it equal to 0 and solve that. Factor this. This is y. We got that over there already. Minus 4 y plus 1 is equal to 0. That's it, right? Y equals 4, y equals negative 1. That's it. So this right here is called the equilibrium solution, or this is also called the constant solution, because these are just the constant functions that will actually satisfy this differential equation. Very nice. All right, are you guys okay with this so far? Oh, by the way, I'm not sure if you guys have noticed my shirt. If I need to figure out the integral of secant, man, it's right here. Integral secant x, tangent x is secant x. If I need to figure out the integral of, I don't know, maybe I need to figure out some trig identity is right here. And then, yeah, I'm sorry, teachers only. Yeah, teachers only. Anyway, hopefully that was enough time for you guys to digest the question. And then I'm going to do the next one. Next one, it's also going to be a little bit, how should I say, not really time consuming. Maybe it's time consuming because you have to enter the things on the calculator, but it's not so bad. Number 8, integral from 0 to 2 e to the sine of 2x dx. I don't know how to integrate that. It's not on my shirt. But don't worry, because we just have to do approximation again. So consider this integral. Part A, we just need to find T4, right? Namely, the trapezoidal rule when n is equal to 4, right? The trapezoidal rule when n is equal to 4. So let's get to work. First off, let's compute delta x. It's just 2 minus 0 over 4. Work that out, you get 1/2. And if you prefer, let's use 0.5. Doesn't matter. And then I will tell you, T4 is equal to the following. You will have delta x divided by 2. So here we have 0.5 and divided by 2. And then you multiply by a bunch of the f of whatever, right? Well, what are the whatevers that we are going to use? I will recommend you guys draw the interval from 0 to 2. So here is 0, here is 2. And then cut this into 4 pieces. So make the cut, make the cut, make the cut. Each width is 0.5. So you know this is 0.5, 1, 1.5, and 2. Why do we need this? Because these are the x values that we are going to use. In my opinion, the midpoint rule is the hardest because you also have to find out the midpoint. Not necessarily hardest, it's just more work to do. Anyway, T4 is equal to delta x divided by 2, and then you just enter the first x value into the function, which is this. So we have f of 0, right? F of 0. And then next, don't forget your coefficient, which you have to have the 2. And you enter the next coefficient, which is 0.5. And then let me just write down one more right here, plus the next one is 2 times f of the next x value, which is 1. And then the next x value is 1.5. And then the last x value, you don't need coefficient, it's just 1. You just need to put an f of that. All right, just like this. Use a calculator to work it out. And this right here, I actually wrote down the solution, right? Because I want to tell you guys what the answer is. This time I will not tell you guys you do it. This is approximately 3.3442. Alright, so this right here is it. This is T4, right? Trapezoidal rule when n is equal to 4. Okay, so quick daily chess improvement. You are watching my live stream while you have online class. Well, as a teacher, I will tell you that might not be a good idea, but as a the owner of this channel, I want to say thank you. But don't tell your teacher though. Anyway, though, let's see. Calculator anonymous. Thank you so much. All right, thank you so much. I will keep up the work and I will do more live stream for you guys if you guys prefer that. All right, now the second part is that you see we use T4, right? That's the trapezoidal rule. But we would like to know if n is equal to 4, that's only going to give me this approximation. I'm not sure how good it is. Sometimes we need to figure out how big the n should be in order to have a good enough approximation. So that's exactly what B is. I will just write this down. How big should n be to... Man, I wish one day I can figure out how to just press a button so that the question will pop onto the screen. I know I need to use like OBS or whatsoever, but like I need to figure out how to do that. But anyway, how big should n be? How big should n be so that Tn is good, right? I wrote down the whole thing on the question, so it's more legitimate if you look at the paper. But anyway, within 0.01, 1, within 0.001 error, right? So that should be the simple way to write it. I didn't really save too many words about whatever. Okay, here we go. For this question, you will have to use the error bound formula. So I will tell you the error bound formula is this. E sub t, right? The error bound formula for the trapezoidal rule. And we don't care about if it's overestimating or underestimating, so we just put down an absolute value for that. And this right here is less than or equal to k times a, k times b minus a to the third power over 12n squared, right? So this is the error bound formula. However, in order for us to use the error bound formula, we will have to figure out what k is. So I will have to tell you, k is the biggest value for the second derivative instead of the absolute value. So f double prime of x, this right here has to be less than or equal to k. So it's the maximum of the absolute value of the second derivative. For x, it's in between of 0 to 2, right? So because we just care about from 0 to 2, that's right. So we have to figure out the k value first, and that's the only part that requires calculus. The rest is just require calculator. All right, we need a second derivative. Here is our function. So let me just write that down. F of x is equal to e to the sine of 2x. Differentiating this guy, f prime, well, first off, I will repeat this, which is e to the sine of 2x. And then, of course, you know, we have to use the chain rule. Multiply by the derivative right here, which is going to be cosine of 2x. But I know you guys can chain rule once. Can you chain rule twice? Yes, we should, because we have to multiply by the derivative right here. Derivative 2x is 2, so that's what we have. This is the first derivative. We need to get to a second derivative, so let's differentiate again, f double prime. Well, for this situation, we have to use the product rule. So I will keep this 2 cosine of 2x times the derivative of this, which is just that. So I will just put down, I will write this down like this though. Multiply by the derivative of this, which is e to the sine of 2x times the derivative of this, which is cosine of 2x, and then multiply by the derivative of that, which is multiplied by 2, right? All right, and then we are going to add the second function, which is e to the sine of 2x, and then multiply by the derivative of the first. Derivative of 2 cosine is going to be negative 2 sine. Derivative of cosine is negative sine, and the 2 stays. And then the input stays the same, which will have the 2x. But don't forget the chain rule. Multiply by the derivative of this, which is another 2 right here. Okay, so that's what we have. And if you care to simplify this, go ahead and do so. And then up to you though, because all we have to do is you put this in the absolute value and use a graphing calculator, because that's what I told you guys in class. Use a graphing calculator to graph this, and then you'll be able to find out the maximum. So I'm going to put this down right here. Right? I'm going to put this down right here for you guys. Well, if you graph the absolute value of the second derivative, right? If you graph this thing, right? If you simplify, good. If you don't, that's fine. Just enter everything, and you will end up with a graph that looks like this. Somewhat like that. And just care about from 0 to 2, right? Just care about from 0 to 2, right? And then what you are going to do is use the function on the graphing calculator and find out the maximum. And the maximum is right here. And I will tell you this right here. It happens when x is equal to 0.754. So this right here is 0.7854. All right, so this is the x. But you care about the y because y represents the absolute value of the second derivative. And the y is 10.8731. So I'll just tell you k is equal to 10.8731. Right? So that's the y. And that is going to tell you the k value, right? So that's all we have to do for this k, okay? And we have this already, so I'm going to erase this so we can come back here. And again, how do we do that? Well, on graphing calculator, on TI-83 or TI-84. All right, now come back here. Well, we want to make sure that the trapezoidal rule is good within 0.001 error, right? All we have to do is put this down first. We know the k is that, so I will put down 10.8731 times the b is that. Because remember, it's integral from a to b. Therefore, b is 2, so put down 2, minus a, which is 0, and then raise that to the third power, and divided by 12, and then the n, we don't know. We are trying to find out the n. So 12n squared, and right here, it says within, meaning no more than, right? So we want this to be smaller than or equal to 0.001, like this. Great. Now I can just multiply this on both sides, and in the meantime, I'll divide this on both sides. And we have 10.8731 times 2 to the third power, divide this here. And I will also keep the 12 down here, 0.001. And then this is less than or equal to n squared. Now notice, the left hand side is positive, and all we have to do is just take the square root on both sides. And just care about the positive square root, of course, because n means to be positive. And all we have to do is enter that on the calculator, and you will see, by reading backwards, you will see that n has to be, let me put up, n has to be bigger than or equal to. Work that out on your calculator, you get approximately 85.13. Well, n has to be a whole number. So finally, the answer is actually just rounded up. So I will just say n should be 86. Technically, I want to write down n should be 86, but if you put down 86, that's totally okay. Right? So that's it. Right? That's it for that. So I will step aside a little bit, let you guys look at this question. Man, how long has this been already for the live stream? I think I'm actually giving a lesson rather than just solving the exam. So, all right. So just a couple more questions to go. I'm providing more details than I was planning. That's why it's taking me a longer time. But it's good, especially for the students, for the viewers who are watching this for your own Calc 2 class. Number 9 is really, really fun. Number 9 is really, really fun. And I want you guys to participate, all right? I want you guys to participate. I want you guys to answer the questions as well. So, number 9, I'm asking you guys to give me examples rather than to just solve the questions. So, give an example of a limit problem. So that A has the indeterminate form. So I'm just going to put down IF. No, I'm still going to spell it out. Indeterminate form of 1 to the infinity's power. So you have to understand what this is trying to ask you. Because you know sometimes when you are computing limit, you first plug in the x value into the function, and sometimes you end up with 1 to the infinity. That's an indeterminate form. And what that means is that you just cannot draw a conclusion yet. But anyway though, I want you guys to give me an example of a limit problem so that it has the indeterminate form of 1 to the infinity's power, but the answer is not 1. 1 to the infinity's power, I don't want this to be 1. So I'm going to see what are the examples that you guys can give me. So this is from the viewers. We'll put this down right here. From the viewers. Right? So you should tell me the limit of whatever goes to whatever. Let's use x. X goes to whatever, and then you should also tell me the function right here. And then in the end, if you work this out, the answer cannot be equal to 1. And in the meantime, if you plug in the value here into the function here, you should first end up with 1 to the infinity's power, right? So go ahead and let me know what you guys have. Okay, Doki. All right, so this right here is by, let me see, by Doki. And this right here, you have, hold on, you guys have a lot. Well, let me see. Limit as x approaching 1. All right, and then we want to have x to the 1 over 1 minus x power. All right, perfect. X to the best friend, like what we talked about earlier. Now, first of all, put a 1 in here, we get 1, yeah? Put a 1 in here, we get 1. And then put 1, and technically you can put down either the plus or minus just to make it, into that form, but it doesn't really matter that much. Anyway, 1 over 1 minus, put a 1 in here, right? And if you don't mind, let me just say this is 1 minus. Why? Because that way I can say that's 1 minus. And then this right here goes to 1, and the bottom is 1 over 1 minus is 0 plus. That's 1, and this is like 0.99. Yeah, so 0 plus. And this right here, 1 over 0 plus is 1 to the infinity's power. Perfect. That's exactly what I'm looking for, right? So a limit like this. The truth is, you don't even need a minus because this is actually a famous question. Do you guys know what the answer right here is going to be? All right, so Marcus, Armando, and I don't know how to say your name, but the last is a K-O-T, COT, equals E. Yes, this right here equals E, right? Perfect. Okay, I'll challenge you guys to give me a few more. The limit as what goes to what, and then what function. In the end, we don't want to end up with 1. Okay, limit examples. I'm waiting for you guys. I'm getting hungry, so hopefully we can finish this soon. So you can eat, I can eat too. Lucas, you are saying this is too hard. I think this is the question that my students complain about. Like, man, after the test, one student said the test was hard because perhaps this question, because usually you are only given the limit and then solve for the question, right? But this time I'm asking you guys for the limit example. But if you notice, it's actually not so bad because I actually went over this in class. So let's see. Well, if you say x is approaching infinity, if you have a solid 1 right here to the x power, this right here, yes, you get 1 to the infinity's power, but this right here is actually equal to 1, right? Because the base right here is exactly equal to 1. So let me just write this down. This right here if you just put that down right here, this is exactly equal to 1. And when you have the base that's exactly equal to 1 to the x power, and x goes to infinity, this will always be equal to 1. So unfortunately though, this right here wouldn't be an example of what we are looking for. Yeah, so wildly, that's why. All right, so this is my default answer, but you can do whatever you want as well. So some possible answers. All right, some possible answers. So you guys know what the question is asking already, so I'm just going to tell you guys. The first thing is, of course, the fact, right? Remember the secret weapon? The limit as x approaching infinity, 1 plus 1 over x raised to the x power. This right here is famously equal to e. If you put infinity right here, and it's good that we were talking about this question because earlier the base right here was exactly equal to 1. Raised to the x power, this will just be equal to 1, all right? But if you look at this, if you put infinity to here, this is 1 plus infinity. Let me just write this down. We get 1 plus 1 over infinity, and then raised to the infinity's power, right? Well, 1 over infinity is approaching 0, so we have 1 plus 0. Let me not do that. So we have 1 plus 0, and then raised to the infinity's power. And 1 plus 0 is approaching 1, and then to the infinity's power. So take a look right here. This is what we have. 1 plus 0 is equal to 1. But the difference between this question and that question is that this one right here, this one is not exactly equal to 1. Rather, you should write this as 1 plus. Why? Because when you have 1 divided by infinity, this is 0 plus. And then when you have 1 plus 0 plus, this is technically 1 plus. Meaning just a tiny number that's a little bit bigger than 1. Right? You can just think about it this way. The technical way to say is you are approaching 1 from the right-hand side. Right? So that's the biggest difference between this and that. Pay close attention to the limit question. Perhaps this is the most confusing limit indeterminate form. Right? So that should be helpful. Now, I will also give you guys a few more. I'm just going to change this a little bit. You'll see it's actually really fun. Okay, number 2. What's the limit as x approaching infinity? And we have 1. Let's do a plus version. 1 plus, and here I'm going to change the x to natural log of x to the x power. Take a guess what the answer is. Well, if you want to work it out, up to you. Go ahead. Pokeball, tell me the answer. You guys got it? What's the answer for this one? Wait, so some of you guys are saying the answer to this is 1 over e. Is that what you guys are talking about? Oh well, I don't know. I think the answer is e though, but like, yeah. Okay, let me tell you. Before I tell you guys the answer for this, let me give you guys another question. The limit as x approaching infinity. Here we have 1 minus 1 over, again, natural log of x. And then raised to the x power. Instead of the plus, I changed to a minus. You guys ready for the answer? First one, well, technically number 2 is infinity. Number 3, 0. just like that. All right, very cool, very cool. Right? Okay, so this right here is first part, 1 to the infinity's power, and as long as you give me an example, then you got the question right. And I'm going to tell you the second part of the question, which is part B. Right? So I'm going to change this a little bit. All right, here we go. Here is part B. Give me an example of a limit problem so that it has the indeterminate form of infinity minus infinity, but the answer is not equal to 0. Infinity minus infinity, but the answer is not equal to 0. So what do you guys have in mind for this one? So I'm going to just put down the possible answers. And then I'm going to take a look at the chart. Let's see. All right, so we have x minus x squared. That is correct. So first off, this is the limit as x approaching infinity, all right? And then just do x minus x squared, like this. And this is by, let me just get your name right. I think the first letter is I, right? I, zero, let's see. I-C-E-R-I-C. I am not sure how to say this name properly, so I'm very sorry about that. But thank you so much for this right here. What's this answer for this one? First, you put infinity to here, which is you get infinity. And then minus, you put infinity right here, which is infinity squared. But infinity squared is still infinity. So this right here is going to infinity minus infinity, right? This right here didn't change, so I'll keep it in blue. Infinity squared is infinity. But all in all, what do we get for this? Negative infinity. Very good. This right here is just equal to negative infinity. Yeah. And once you know this example, you can modify it to whichever ones that you want, right? If you change it, then you get positive infinity, right? So that's pretty cool. Because this time, x is so much smaller compared to x squared. So this infinity minus this infinity, you actually end up with negative infinity because this is much bigger. All right? Do you guys have another one for me? Do you guys have another one? X minus e to the x, same idea, right? Do you guys have another one that actually ends up to be a finite value? 1 minus, well, trying to get infinity minus infinity, all right? Okay, so I get a square root 1. So Nicholas, so hold on one sec, I'm going to write this down. Very nice. Number 2, the limit as x approaching infinity, square root of x squared, square root of x squared plus 3x plus 1. If you put infinity to here, you will get infinity. And then minus square root of x squared plus 1. All right, this right here, yes, it's in the infinity minus infinity form. And this is by Nicholas, right? By Nick. But do you guys know what the answer to this one is? What the answer to this one is? Alright, so let me know what the answer is. In the meantime, I will tell you guys my choice, right? First one, it's actually from the homework. This right here is the limit as x approaching 1 minus ln x to the 7 minus 1, and then minus ln x to the 5 minus 1. Technically, when you do this, you actually get negative infinity minus negative infinity, but this is actually still in the form of that, so it doesn't really matter. I will tell you, This right here gives you ln of 7/5, right? So that's the answer that we have in my class, because I have this right here being assigned to the class. All right, now, what's the limit as x approaching infinity? Of the same thing, ln x to the 7 minus 1 minus ln x to the 5 minus 1. This right here is infinity minus infinity. So that's, definitely fits that criteria. This right here gives you infinity, which is not 0. Yeah. And how about this one? How about this one? Do you guys have the answer for that? Muhammad, 3/2. And I believe that is correct. Muhammad says 3/2. And then Nog also say 3/2. So yes, this right here is 3/2. All right. So take a look of this, and you see on the exam you can actually just put down an answer and then just move on. But like in the live stream, I think I'm having way too much fun, so that's why I don't want to leave this question. But anyway, though, take a look, and perhaps later on I'll do a video with all these 7 indeterminate forms. That's not ending out the answer that you expect. Yeah. So number 9, and then we have 4 more to go. And I also have to make sure that my battery, I have enough battery to do the rest. So let me just finish the other ones. Okay, number 10. Number 10. Here is the deal, right? So I'm just going to tell you what we have. Right? This is what we have, right? So you guys can see, maybe. No, like this, a little bit. All right, so you pretty much are putting fish into a lake, and initially you put down 400 fish, right? And then you estimated the carrying capacity is to be 10,000, and after 1 year you have double the amount. Assuming you have a logistic differential equation, we would like to know the population of the fish. When will it get to 5,000? So here is the deal. Let me just tell you the following. Assuming we are dealing with a logistic differential equation, assuming the situation is logistic, all right? So let me just write that down. And I will tell you initially, actually, let's do this. I'm going to say let P of t, P stands for the population of the fish. So be the population of the fish, right? Okay, whenever you are solving a word problem, it's always a good idea to write down what you know and what you want to know. What we know is, first, it's logistic and also that, but let's see. Let me actually put down the initial condition first. Initially, we have 400 fish, right? Initially, we have 400 fish. And we also know the capital M, which stands for the carrying capacity. This right here is assumed to be 10,000, right? And another thing that we know is P of 1 is doubled it. So we have 800 right here. Right? P of 1 is double the amount of that. And we would like to know, right? We would like to know at what time, so that the population at that time, we will get 5,000 fish. So that's pretty much all you have to write down. And here is the deal. Okay. We also have to put on the logistic differential equation, right? So I'm just going to write that down right here for you guys. when you have the adjusted differential equation, it's in the following form: dp dt. This right here is proportional, meaning you just write down it's equal to k, proportional to the population, and also to the factor of 1 minus p over m, like this. All right? So this right here is the differential equation, and here are the initial conditions, and this right here is our m, which is the carrying capacity. So this right here is the carrying capacity, maximum pretty much. All right? Well, here's the deal. You can do this two ways. The first way is go ahead and solve this as how it is. And that's going to take you another like 10, 15 minutes or whatsoever. But life does not have to be that hard. Otherwise, this test will consider to be long. You don't have to do it like that. Because if you look at the file that I have for you guys in the description, I actually solved the general solution for you guys already. So here is the deal. When you have dp dt equals kp times 1 minus p over m, which is 10,000. From here, I will tell you, hey, you know what? P of t is nicely equal to m, which is the 10,000 on the top, over 1 plus c, right? Right here, we have to figure out what the c is, so I'll put this down, c. And then we multiply by e to the negative kt. You have a general form for this. And I let you guys use that if you recognize, hey, you set up this differential equation, that's exactly the one that we can use, right, from the cover page of my test. Better yet, I will tell you, for the c, it's actually very easy to find because it's just the maximum, or the carrying capacity, which is 10,000, and then minus the initial, which is this, minus the 400, divided by 400. So c is equal to 24, right? So that's pretty much all you have to do to solve for the amount equation. And then for the rest, you just have to work out the constant k and then figure out the t for that. So here we go, let's see. We know p of 1 is equal to 800, right? P of 1 is equal to 800. Why? Because we want the amount to be doubled, right? All right, so here is the deal. This right here is equal to that, which is 10,000 over 1 plus c is 24. So here is the 24 for Kobe Bryant. Yeah, rest in peace, of course. And then here we have e to the negative k. K we don't know. And then the t is 1. Because it says after 1 year, so the t right here is 1. So that's what we have, all right? That's what we have. And then just go ahead and solve this equation, and let me show you guys the power. Let me show you guys a super way to solve for k, right? I'm going to multiply this on both sides first. So I'm looking at this as 800 times this, which is 1 plus 24 e to the negative k. Yeah, this is my finger. And this is equal to 10,000, right? You guys ready for the super way to solve this? Here we go. To solve for k, right? To solve for k, what we do is you divide the 800 on both sides. So right here, you have the 10,000 divided by 800. Go ahead and do that. So this is out. But you still have to minus the 1 on both sides. So minus 1. So this is out. And then you have to get rid of this. So we will have to put this in the parentheses and then divide it by 24, right? So this is out. And then we have to get rid of the e, which we do natural log. So natural log of this guy. Now this is out. In the end, you get negative k, but we don't care about negative k. So multiply negative on both sides. So this is what we have, just like that. And k will be approximately, right? K will be approximately 0.7357. So let me see if I can fit in better. right here. This is approximately 0.7357. 4 decimal places, right? Okay, now you can just put this back to the k right here, and the population right here is 5,000 that you want to get. So now you have the equation, which is 10,000 over 1 plus 24, and then you have E and negative KT, right? So negative K is 0.7357, and then you have the T right here, and you want this to be 5,000, right? So that's what you are going to do. And again, you can solve this by the super way. So multiply this on both sides, and let's see, I don't have enough space. All right, I'm going to just write down the T for you guys, right? Let's see, this is the super way to solve this. Multiply this on both sides, and then you start with 10,000. Yeah, you have to divide this on both sides, so divide the 500. Yeah, and then you have to get rid of the 1, so minus 1. And then you have to get rid of the 24, so divide it by 24. And you have to get rid of the E, so natural log of this. And you have to get rid of that, so 1 over negative 0.7357. All right, and I will tell you, T is approximately, let's see, 4.32 years. That took a while, but just go ahead and do it. It's not so bad. All right. Okay, then what we're going to do next is the following question. So when we are doing the improper integrals, of course, there will be the comparison theorem question. So we are going to use the comparison theorem to do the following. This is number 11. Here is the integral from 2 to infinity. And we have x squared minus 2 over x to the 5 plus 2x to the third power plus 6 dx. We would like to know if this right here converges or not by using the comparison theorem. So here we go. Well, integrating this is too bizarre. Just consider the dominating part, which is this and that. And go ahead and write down the 3 steps. First, write down what we know, which is just going to be a smaller version of this integral that we know much better. If you look at the integral going from 2 to infinity of x to the second power over x to the 5, well, this can be nicely reduced to be the integral going from 2 to infinity, and we have 1 over x to the third power dx. This right here, by the p integral, this is 3, which is bigger than 1. That means this integral actually converges, right? Cool. Now, what we are going to do next is we are going to check if this integral that we are dealing with is less than or equal to the convergent integral that we know. If so, congratulations, we can draw a conclusion and then we can move on. So check the integral going from 2 to infinity, and we have x squared minus 2 over all that stuff, x5 plus 2x cubed plus 6 dx. Hopefully, this is less than or equal to, but I don't know yet. Integral going from 2 to infinity, and I'm just going to put down that. All right? So this is the check that we have to do. And be sure you set out the correct inequality, because otherwise, you are not just making like an innocent mistake. That's a crucial mistake, right? You are trying to show this right here is less than or equal to a convergent. And notice that everything will be positive on the interval from 2 to infinity. So, you can put that down. But usually I don't trick my students. You can always put that down, right? Because the integrals are going from 2 to infinity, we can just compute it inside, namely x squared minus 2 over x to the 5 plus 2x to the third power plus 6. Is this less than or equal to 1 over x to the third power? And we just care about when x is going from 2 to infinity, so x is greater than or equal to 2. Now, because everything is positive, we can cross multiply. That's perhaps the way that people like. Multiply this right here. We get x to the third power x squared minus 2. Is this less than or equal to? Oh, that x5 plus 2x cubed plus 6. Well, this right here is x to the 5 minus 2x cubed. Is this less than or equal to x to the 5 plus 2x cubed plus 6? Both of them have x to the 5, get rid of them. And you can see that if you really want to do whatever you want to do, you can bring this to the other side and you get negative. You don't have to do this. You really don't have to do this. You really, really don't have to do this. Life doesn't have to be that hard, but I will do it anyway. Is this true? This is true because x to the third power times negative 4. This is always negative. Is this less than or equal to a positive 6? Yes, right? This is true on this interval, right? So it's true. Congratulations, because with this we can move on. Move on to our conclusion. And this is just like how you write your English essay. 3 parts, right? The first part is what? Introduction. Hey, you are telling me that what do you know about an easier version of the improper integral, right? Introduction, what you know. Second, when you write the essay is the body paragraph. And that's exactly our check. And for this check, we are just doing algebra to check the inequality. If your body paragraph supports what you said, if your check works out, then, for your English essays, you draw your conclusion, just like what we are about to do right here. The conclusion is that the integral that we are doing, integral from 2 to infinity, x squared minus 2 over x5 plus 2x third power plus 6. This right here also converges. And if you guys have seen my videos on the improper integrals, comparison theorem, and things like that, I like to tell you guys, also, it's a nice word when you are doing these kind of things. Because remember, we can only use convergent to show convergent. So also converges, it checks. Also converges by the comparison test. Right? So that's it. What you know, and do the check, and then draw the conclusion. All right. Good, huh? Now, 2 more questions. I'm glad that I'm not doing 100 questions, because otherwise, I don't know when I'll be able to sleep. I was going to say, when am I going to go home? But I'm home already, so. Anyway, the next one is just a straightforward integration question. Integral of ln2 to infinity 1 over square root of e to the x minus 1 dx. All right, let me tell you it converges. And let's see. Are you guys still watching? Are you guys still here? I don't know if I'm talking to the new viewers or the viewers who have been watching this for the whole thing. If you have been watching this for the whole thing, thank you so much. Anyway, take some time and let me know what we can do to integrate this guy. Hello. Thank you for staying, and thank you for supporting. And Wally, I know you were here earlier, so that's cool. And Oscar! Whoa, Oscar, how are you doing? Hopefully you are doing well, and let me know. Okay, so I see u is equal to e to the x plus minus 1, e to the x minus 1. That's okay, but if you do that, you will have to do 2 substitutions. It's actually easier if you let u equal to the square root of e to the x minus 1, right? So I'm just going to work this out rather quickly because we did the integration test last time already. So this is our u, and then we see du is equal to 1 over 2 square root of e to the x minus 1, and use the chain rule. So we have e to the x, and then we have the dx. And then I'm going to multiply this, the reciprocal on both sides. So we get dx equals, here we have 2 square root of e to the x minus 1 over e to the x. And then we have the du. Cool. Now, we are going to take this integral from the x world to the u world. And I'm just going to put it down right here. All right, remember, x is going from ln2, right? So when x is ln2, you put it here, you see that u will be square root of e to the ln2 minus 1. E to the ln2 is just 2. 2 minus 1 is 1. Do the square root, you still get 1. 1. Here, integral u goes from 1. Next, put infinity to here. U is e to the infinity minus 1. E to the infinity is infinity, minus 1 is still infinity, to the square root of infinity is still infinity, so infinity. U go from 1 to infinity. Right? Okay, 1 over this guy is our u. Alright, that's good. And then dx is this guy. We have 2. Right, so multiply by 2. But notice this guy, square root of e to the x minus 1. This is what? This is nicely equal to our u. Let's put that down. Right, let's just put that down. Alright, what else do we know though? On the bottom, we have e to the x. If you put down over e to the x, the problem is that, remember we are still in the u world, right here. The e to the x, there's nothing that we can cancel out. That's too bad, but it's also not so bad. Why? Because we can actually look back to this. Well, u is equal to square root of square root of e to the x minus 1. Square both sides, you see u squared is equal to e to the x minus 1. And I can move the 1 to the other side, so that means e to the x equals u squared plus 1. So I'm going to put this down right here for the e to the x. Right? So we have this over u squared plus 1. And by the way, the 2 should be in red. Yeah? All right. Now, you see that e to the x, you see that u and u cancel out very nicely. And then here, we just have 2. That's the constant multiple, and that's it. And then we have to just integrate from 1 to infinity. And remember, we are in the u world, so everything's nice. And we just have 1 over u squared plus 1 du to integrate. Right? That's what we have. And I kind of forgot about that. Let me see. U is the same as x, so I see this one. 1 over x squared plus 1 is the same as 1 squared. Okay, so that's inverse tangent. Okay. The answer to this right here is inverse tangent. So we get, let's see, put it down right here, equals 2 times inverse tangent. And then inside is u. And then we are doing everything in the u world. So u goes from 1 to infinity. Right? And just continue this. That's it. 2 inverse tangent of infinity minus 2 times inverse tangent of 1. Right? First part, second part, and subtract. Now, what's this? What's inverse tangent of infinity? It's not on my shirt, unfortunately, so help me out with that. What's inverse tangent of infinity? Pi over 2. Thank you so much. So here we have pi over 2. In the meantime, what's inverse tangent of 1? pi over 4. Thank you so much. All right, so this times that is just pi minus this, and that is pi over 2, right? All in all, pi minus pi over 2 is just pi over 2. All right, done. In fact, this is the exact same homework question, so yeah, it's like a freebie if you did the homework legitimately, right? All right, the last question. You might be thinking like all the exam questions right here is like pretty long, but well, I'm just doing a lot of explanation, so I want to just make sure that it's clear. The exam shouldn't be too bad. And the last question is just that you can leave the exam with a sweet note. Number 13. Here we are going to calculate a nice limit. The limit as x approaching 0. Right? This is going to be the fraction bar that we need. And here we have e to the 4x. Oh man, this is pretty long. And then minus 4x, and then minus 1. And then 1 minus cosine x. Don't worry, the question is not so crazy. It's just that, as I told you, it's just so that you can leave the exam with a nice note, right? A sweet note. All right, here we go. Putting 0, you get 0 over 0. So we can do L'Hopital's rule, which is very nice. Go ahead, d dx that, and d dx that. And by the way, I just really want to say this. I just really want to say this, right? I have seen you guys, when you are doing the L'Hopital's rule. Let me just write down the same question again. 1 minus cosine x. Yeah, I know that you might not have enough space in the front to put down d dx, but be sure you don't write down d dx here. Be sure you don't write down d dx at the end. That just doesn't make sense. Please don't do this. Stop it. Don't do this, right? Always put the d dx in the front, right? And open the parentheses for that. Don't do this, right? Don't do this. All right, enough talking about that. Here, what we did was, because it's a 0 over 0 situation, we are using the L'Hopital's rule. Well, we have the limit as x approaching 0. On the top, the derivative of this is e to the 4x, but don't forget the chain rule multiplied by the derivative of this, which is 4 right here. All right, the derivative of this is minus 4, and the derivative of this is 0, so that's it. On the bottom, the derivative 1 is 0. The derivative of negative cosine is positive sine x. All right, but we are not done yet, because if you put in 0 into all the x, we still get 0 over 0. So, if it's a 0 over 0 situation, I think we are making a good progress. So go ahead and do the derivative on the top and then the derivative on the bottom. L'Hopital's rule. So here we have a limit as x approaching. Why do I want to write infinity all the time for this question? I don't know. The limit as x approaching 0. Here we have 4e to the 4x. But chain rule says multiply by 4 again. And the derivative of negative 4 is just 0. And the derivative of sine x is cosine x. So that's what we have. Now, when we put in 0 into here, e to the 0's power is 1. Cosine of 0 is 1. So, 4 times 4, I hope I get this right. The answer is 16 for that, right? So as I told you, the last question is just so that you can leave the exam with a pretty sweet note for that, right? So, that's it. Hopefully you guys are doing well, and hopefully you guys enjoyed this live stream. And next time, I think I want to just probably do more live streams so I can interact with you guys, and also I can put my exams out there. So if you are taking a class right now, hopefully you can find this to be helpful. And it's actually easier for me to do a lot of questions at a time, so I can get all this done. So I plan to do some of my old Calc 1 and old trig exams and some algebra videos to just help students. And the next test for my Calc 2 class, it's in like 3-4 weeks. It's about sequence and series. And again, after the test, I will do the live stream for you guys, right? Okay, so this is it, and have a good evening, or maybe have a good day, depending on where you are. And that's it. Bye.